Today's lesson involves solving equations by multiplying or dividing decimals. Before we do the equation part, we're going to just take a few minutes to go over the basics of multiplying decimals. Then we'll go over the basics of multiplying or dividing decimals as well. Then we'll put them into practice solving the equations. When we're multiplying with decimals, when we get to the final product, we want to add the decimal places in each of the factors and then put that amount of decimal places into the final product. So we'll rewrite this, and this is a lesson without calculators right now. We do not have to line up our decimals when we are multiplying. We'll simply count up the decimal places at the end. So treat this as a regular multiplication of two digits. And when you're done multiplying each of the two rows or two terms, we'll add up the subproducts. Then we'll see that there are two decimal places in this first factor and one in the second, which gives me a total of 3 places. So I'll count from right behind that last digit in 1, 2, 3, and my answer is 5 and 768 thousandths. On to problem 2. I have 23 and 5/10, and I want to multiply by 13 hundredths. Again, decimals do not need to be lined up. We'll just simply multiply. 15, 9 and 1 is 10, 6 and 1 is 7. On to the second row, multiplying by 1, and let's add those two subproducts. There is just one decimal place in the first factor, and there are 2 in the second, which once again I need 3, counting in 1, 2, 3, 3 and 54 thousandths. One last one before we put this into equations. We've got 4 and 532 thousandths times 3 and 7/10. We're multiplying and we'll get 7 times 2, 14, 21 plus 1 is 22, 35 and 2 is 37, and 7 times 4, 28, and that gives me 31. Second row, I'll save that placeholder here and I'll just multiply everything by 3. 9, 15, that's 4, that's 12, that's 13. Adding up our subproducts. Counting up decimal places, there are 3 in the first, 1 in the second. I need 4 decimal places, 1, 2, 3, 4. I get a product of 16 and 7,684 thousandths. So what does that look like in equation form? If I'm solving equations that involve division, I'm going to do the inverse. I'm going to multiply, which means I need to multiply both sides by 4/10. Once again, I'll rewrite this as a long multiplication. And it just so happens that the decimals line up in this one, but it's not necessary. I need 2 decimal places in my product, and I get 1 and 4 hundredths. This next one is multiplying by a whole number. So I'll have a negative 3 and 7/10 times a negative 3. 3 times 7 will give me a 21. That's 9, 10, 11. And we have a negative times a negative, which gives me a positive. There's only one decimal place. I get 11 and 1/10. Third example. I'm going to multiply both sides by a negative 1 and 2/10. That gives me 16 and 1. That's 6 and 1 is 7 and 2. Second row, I've got 8, 3, my mistake, and 1. Add them up, we get 6 and 15 and 6 and 1, 1 decimal place, 2 decimal places, 16 and 56 hundredths. On to the second type of problem for today. We want to look at dividing decimals. So again, before we put it into the equations, let's practice the skill. This is the first number is my dividend, the second number is my divisor. And the rules tell us to convert this divisor into a whole number because we don't want to divide by a decimal. So if I write this in the long division method, this says 3 and 44 hundredths divided by 4 tenths. Again, 4 tenths is a decimal, so I'm going to move that decimal one place over to make it a whole number. It's basically multiplying by 10. Whatever I do to the divisor, I have to do to the dividend, and make sure you put that decimal right up in your quotient. And now we're ready to divide. This will go in 8 times, which is 32. Subtract and bring down. And I see that's going to be giving us a remainder of 0. And I'm going to find out that the quotient is 8 and 6 tenths. Let's see a second example. I have 2 and 875 thousandths divided by 5 hundredths. This time I'm going to move my decimal over 2 places, which is multiplying by 100. And I'll do the same thing in the dividend. Bring that decimal right up to the quotient, and then we divide. You subtract and bring down your next value. I'll see that that will go in 7 times, which is 7 times 5 is 35. I'll subtract and bring down my next digit, and that's going to be a 5. And it leads me again to a remainder of 0. So my quotient is 57 and 5 tenths. Last practice problem. I'm dividing again, and this time I'm dividing by 3,000. So I have 700 and 362 thousandths divided by 3 thousandths. Let's move that decimal over 3 places. The reason I'm putting up in the quotient because sometimes we have to add zeros, but we might not have to in this problem. This will go in twice, which is 6. Subtract and bring down. 4 times 3 is 12. We'll subtract and bring down. 5 times 3 is 15. Subtract, bring down the last digit, which is a 2, and that leaves me with a remainder of 0. So my answer becomes 2,454. So there you have a quick practice or review of multiplying and dividing by decimals. But the final step here is saying, let's divide. If I divide both sides to isolate my variable x, I'm going to get 5 and 4 tenths divided by 9 tenths. Again, we follow that same process of moving that decimal over, and we'll see that will go in 6 whole times. X is equal to a whole number 6. Not always will they come out to a whole number, but sometimes they will. Let's divide both sides by 8 tenths. So if I'm going to take that 1 and 6 tenths and divide by 8 tenths, it just so happens that this again comes out to a whole number. And let's do one more. Final problem of the day, 6 and 36 hundredths divided by a negative 4 tenths. Move that decimal over once up in the quotient. Now I know that the signs are unlike, so my answer is going to be negative on this one. Let's divide, subtract and bring down. That's 20. Subtract and bring down, and 9. X is going to be equal to a negative 15 and 9 tenths. You'll do a little practice tonight, and if need be, we'll revisit this next class.